Hello friends, welcome to lecture series on essential mathematics for machine learning. So, in the last lecture we have seen that if a random variable is given to you, its PMF or PDF is given to you, that how can you find expectation or variance of that x. So, we have seen in that lecture that if we want to find out expectation of x, then this is nothing but summation x of x when x is discrete, and it is integral from minus infinity to plus infinity x f x dx when x is continuous. And variance of x is simply expectation of x square minus expectation of x whole square. So, now in this lecture we will see that what are the some of the important distribution functions, mainly Gaussian distribution or normal distribution which is used in machine learning, and how can you find out mean or variance of those distribution functions. So, first distribution function is basically we will use, that is binomial distribution function, discrete case. So, before going to binomial distribution, what do you mean by Bernoulli's trials? So, a series of trials are referred to as Bernoulli's trials if the following assumptions hold. So, what are those assumptions? Number 1, there are only two possible outcomes for each trial, either success or failure. So, if we are doing some experiment, okay, and there are only two possibilities, either pass or fail, either success or failure. So, that is the first assumption for Bernoulli's trial. The second assumption is the probability of success remains same for each trial, it will not change. Okay. Next is the outcomes from different trials are independent. Okay. The first trial will not affect the other trial, the second trial will not affect the third trial, and so on. And there are finitely many such trials conducted. It is not infinite, this is finitely many. So, if these four assumptions hold, then the series of trials which we are conducting are called Bernoulli's trials. Now let us come to binomial distribution. What do you mean by binomial distribution? So, if n independent Bernoulli's trials are performed, then the random variable x denoting the number of successes in the n trials is said to follow the binomial distribution denoted by x, b and p. This is a notation where p is the probability of success in each trial. Here p is the probability of success in each trial and denotes the number of trials, total number of trials. If there are x successes in n trials, then we have n minus x failure, of course, because if out of n trials we are having x success, that means remaining trials are failures, and that means n minus x are failure. So, the probability of x success will be given by, see, the probability of x success, now out of n there are x success. So, it is NCX. NCX is simply factorial n upon factorial x into n minus x, factorial n minus x, multiplied by Px, which is the probability of success of getting x trials, x success, and this is 1 minus p is a failure, and there are n minus x failures. So, power is n minus x, and of course, x is varying from 0 to n, meaning when x is 0, that means all are failures. When x equal to 1, that means 1 success, x equal to 2, that means 2 success, and when x equal to n, similarly that means n success, all success. So, this distribution is basically called binomial distribution. Now, of course, if you see this particular distribution, which is f x equals to p x equal to x, which is given by n c x p raised to power x or q raised to power n minus x, where q is nothing but 1 minus p and x is varying from 0 to n. So, if you see this distribution, of course, for any x between, if for any x from 0 to n, it is always non-negative. So, first condition is that f x is always greater than or equal to 0 for all x, that is of course satisfied. Now, if you see a sum of all f x for x, so if you calculate this, so it should be 1 if it is a distribution function. So, let us see. So, it is NCX p raised to power x q raised to power n minus x, and x is varying from 0 to n. So, it is nothing but p plus q whole raised to power n, okay, as per the binomial theorem, and p plus q is 1. So, 1 raised to power n is 1. So, for a discrete case it is a PMF. How we can find out expectation of this random variable x, and how we can find out variance. Okay. So, if you want to find out expectation of x, expectation of random variable x, so that will be summation x f x, x is varying from 0 to n. So, this is nothing but summation x from 0 to n. So, this is x, this is NCX p raised to power x q raised to power n minus x. So, let us try to compute this value. So, let us expand this p plus q whole raised to power n. This is nothing but summation x varying from 0 to n. This is NCX, this is p raised to power x q raised to power n minus x. Okay. Now, let us differentiate both sides with respect to x. So, differentiate both sides, both the sides with respect to x. So, what we get? We get both set to p, sorry, with respect to p. So, it is n p plus q raised to power n minus 1, it is summation x varying from 0 to n. So, it is x and cx p raised to power x minus 1 q raised to power n minus x. Okay. Now, we want this value x and cx p raised to power x we need, q raised to power n minus x. So, you multiply both sides by p. If you multiply both sides by p, so it will be n p into p plus q whole raised to power n minus 1 plus summation is equal to summation x from 0 to n x and cx p raised to power x q raised to power n minus x. So, this is nothing but expectation of x, and that this value is nothing but because p plus q is 1. So, it is nothing but n p. So, this implies expectation of x is n p. We can say that mean of binomial distribution is n p, where n are the total number of trials and p is the probability of one success. Okay. Probability of success in probability of success basically p. Okay. Now, if you want to compute variance of x, so how can we compute variance of binomial distribution? Okay. So, variance will be given by, we know that it is expectation of x square minus expectation of x whole square. So, this we know that it is n p. So, we have to compute this. So, expectation of x square as per the definition, it is summation x from 0 to n x square into n c x p raised to power x q raised to power n minus x. Okay. It is sorry, it is x square. Okay. So, we want to find out this value. So, again what is p plus q raised to power n, as we have already seen, it is summation x from 0 to n, it is n c x p raised to power x q raised to power n minus x. You differentiate both sides with respect to p. So, it is n p plus q whole raised to power n minus 1 summation x varying from 0 to n, it is x n c x p raised to power x minus 1 q raised to power n minus x. Now, you want x square here, okay, for this. So, if you want x square here, so first you have to make it p raised to power x. So, you multiply both sides by p. Okay. If you multiply both sides by p, so it is p raised to power x q raised to power n minus x. Now, again you differentiate with respect to x because you want x square. So, again you differentiate with respect to x. So, that is nothing but n times. So, first as it is derivative of second will come here plus second as it is derivative of first will come here, and that is nothing but summation x varying from 0 to n, it is x square n c x p raised to power x minus 2 into q raised to power x minus 1, sorry, it is and q raised to power n minus x. Now, as p plus q is 1, so p plus q is 1, so it is n, it is n p minus p plus 1 is equal to this value. Okay. Now, for this again you want to compute this. So, for this you again multiply both sides by p. So, you multiply both sides by p. So, what is expectation of x square finally you will get? This you get as n p into n p plus 1 minus p. Now, what will be variance of x now finally? Variance of x will be expectation of x square minus expectation of x whole square. So, that will be n square p square plus n p into 1 minus p minus n square p square. So, this cancels out. So, it is n p q or n p into 1 minus p. So, that is how we can compute mean and variance of this random variable. Okay. So, let us discuss this example. So, this example is based on binomial distribution. The probability that a new building violates the building code is 1 by 4. What is the probability that a building inspector who randomly selects 4 of the new buildings for inspection will catch none of the buildings that violate the code? So, what is n? First identify n. What is n? Number of new buildings are 4. What is the probability of success? Here success is violating the code and that probability is 1 by 4. So, that means 1 by 4. So, what is q? Q is 1 minus p, that means 3 by 4, not violating the code. We want that out of all these 4, the inspector will catch none of the building that violate the code. That means for x equal to 0 we have to find. So, that means x equal to 0 and that is nothing but 4 c 0. From here you can get it is 0 and that means 3 by 4 is to power 4. So, that means 81 upon 16 into 16, that is 256. So, it is 18 upon 256. Okay. So, in this way we can find out. Now, the next distribution is Poisson distribution. So, let us suppose a random variable x is follow a Poisson distribution which is denoted by p lambda. This is here parameter is only one, which is lambda. In the binomial distribution we are having 2 parameters n and p. Here we are having only lambda and its PMF is given by lambda raised to power x e raised to minus lambda upon factorial x, and x is varying from 0 to infinity. Okay, lambda is greater than 0. So, one can easily verify that it is a PMF because this is greater than equal to 0 for every x, number 1, and if you take the summation over entire x from x is varying from 0 to infinity, then this sum comes out to be 1, that is easy to verify. Now, if you want to find out the mean or variance of this random variable x which is following Poisson distribution, so how can you find? So, let us see. So, what is the PMF of this? This is lambda raised to power x e raised to power minus x upon factorial x. X is from 0, 1, 2 and so on. So, what is expectation of x? Here it is summation x p x. Okay. So, what is the PMF of this? It is okay, lambda raised to power x e raised to minus lambda, okay, fine. So, it is here it is e raised to power minus lambda, okay. So, it is x from 0 to infinity. So, it is summation x from 0 to infinity it is x lambda raised to power x e raised to power minus lambda upon factorial x. So, that will be summation. So, it is lambda raised to power x e raised to power minus lambda upon factorial x minus 1. Of course, when x is from 1 to infinity now, because for 0 it is obviously 0. Now, you can take one lambda common. So, it is x from 1 to infinity, again it is it is e raised to power minus lambda. Okay. So, it is lambda raised to power x minus 1 upon factorial x minus 1, and it is e raised to power minus lambda. So, this e raised to power minus lambda will come out because it is free from x. So, it is lambda e raised to power minus lambda, and when x is 1 it is 0 upon 0, lambda raised to power 0 upon factorial 0. So, we can write x from 0 to infinity lambda raised to power x upon factorial x, and this value is nothing but e raised to power lambda. So, it is lambda into e raised to power minus lambda into e raised to power lambda, which is lambda. So, we can say that mean of random variable following Poisson distribution is lambda. So, now if you want to find out its variance, so its variance will be expectation of x square minus expectation of x whole square, as we already seen. Now, what is expectation of x square for this? This is summation x from 0 to infinity x square into lambda raised to power x e raised to power minus lambda upon factorial x. So, this is x from 0 to infinity. Now, this can be written as x into x minus 1 plus x upon factorial x into lambda raised to power x into e raised to power minus lambda, which is x from 0 to infinity 1 upon factorial x minus 2 plus 1 upon factorial x minus 1 into lambda raised to power x e raised to power minus lambda. So, here for this summation x starts from 2 and for this summation x starts from 1. So, we can say that it is summation x from 2 to infinity, it is lambda raised to power x e raised to power minus lambda upon this plus summation x from 1 to infinity lambda raised to power x e raised to power minus lambda upon factorial x minus 1. Now, you can take lambda square common from here to make the power and this factorial same, so that it will be converged to e raised to power lambda. So, this will be, you can say lambda square into e raised to power minus lambda into e raised to power lambda will come, and plus it will be lambda into e raised to power minus lambda into e raised to power lambda will come. So, this will be nothing but lambda square plus lambda. Now, you can find out variance using this expression. So, finally, variance will be lambda square plus lambda minus lambda whole square. So, it is lambda. So, we can say that mean and variance of a random variable following Poisson distribution are same, both are lambda. Now, for which type of problems it is used? Poisson distribution serves as a model for various experiments and phenomena associated with weighting of an occurrence. In queuing theory, we basically use such models. For instance, the number of customers arriving at shop in a given time interval can be modeled using Poisson distribution. So, let us quickly do this example. Now, at a checkout counter, customers arrived at an average of 2 per minute. So, lambda is 2. Okay. Then what is the probability that at most 2 customer will arrive in any given minute? So, at most 2 customer means p x is less than or equal to 2. So, that means p x equal to 0, p x equal to 1 plus p x equal to 2. So, we know that for Poisson distribution it is lambda raised to power x. So, x is 0 into e raised to power minus lambda upon factorial x plus lambda raised to power 1 e raised to power minus lambda upon factorial 1 plus lambda square e raised to power minus lambda upon factorial 2. So, this is now lambda is 2, as given the problem lambda is 2. So, lambda is 2. So, it is e raised to power minus 2 will come here. So, it is 1 plus lambda is 2 plus it is 4 upon 2. So, this is nothing but 5 e raised to power minus 2. That is the final answer for this problem. So, now we will discuss few example based on Poisson distribution. So, let us discuss the problem number 1 first. At a checkout counter, customers arrive at an average rate of 2 per minute. So, that means it is lambda. So, what is lambda in Poisson distribution? As we already discussed, lambda is simply mean or variance, mean and variance for Poisson distribution are same. So, once if you are talking about average of 2 per minute, that means it is lambda. So, what we have to calculate? What is the probability that at most 2 customers will arrive in a given interval, in a given minute? Okay. So, how to compute that? See, in this problem lambda is what? Lambda is 2. 2 what? It is 2 customers per minute. It is 2 customers per minute. And we have to calculate probability for x at most 2 customers. Okay, x denotes number of customers, at most means should be less than equal to 2. So, that means we have to compute p x equal to 0, x equal to 1 and x equal to 2. So, since we know that probability for x equal to x in Poisson distribution is simply e raised to power minus lambda, lambda raised to power x upon factorial x, where x is from 0, 1, 2 and so on. So, for x equal to 0, you substitute x equal to 0 over here. So, it is e raised to power minus lambda, lambda raised to power 0 upon factorial 0 plus e raised to power minus lambda, lambda raised to power 1 upon factorial 1 plus e raised to power minus lambda, lambda square upon factorial 2. Now, e raised to power minus lambda will come out, it is 1 plus lambda square upon 2, and what is lambda here? Lambda is 2. So, it will be equal to e raised to power minus 2, 1 plus 2 plus 4 upon 2, which is equal to 5 into e raised to power minus 2. So, this is the probability of at most 2 customers in a given minute. Okay. Now the second problem is, an office board receives phone calls at a rate of 3 calls per minute. So, that means it is lambda here. Lambda is what? 3 calls per minute. Find the probability of receiving no calls in 1 minute interval. So, how we will compute the first part of this? So, first of all, here in this problem lambda is what? Lambda is 3 calls per minute. Okay. Now, what to find out? Probability for x equal to 0. See, what is there in the problem? Receiving no calls. Receiving no calls means what? X equal to 0. So, how to find probability for x equal to 0 in this case? So, it is e raised to power minus lambda, lambda raised to power 0 upon factorial 0, and what is lambda? Lambda is 3. So, it is e raised to power minus 3 upon 1, that is e raised to power minus 3. So, this is how we can solve the first part. Now, see the second part. Now, in the second part we have to find the probability of receiving at least 4 calls in 3 minute interval. Now, here see, in the first part lambda is 3 calls per minute. Now, in the second part we have to compute at least 4 calls, probability of getting at least 4 calls in a 3 minute interval. So, that means we have to compute new lambda, which is not in 1 minute interval, it is now in 3 minute interval. So, if it is for 1 minute, if it is 3 calls, for 3 minute it will be what? 9 calls at an average. So, for this part lambda dash or lambda will be what? It will be 9 calls per 3 minute. Okay. So, what we have to find? We have to find at least 4 calls. So, at least 4 calls means p x should be greater than or equal to 4. So, that means 1 minus p x less than at least 4 calls, yeah, fine, less than 4. Okay. It is at least 4 calls, it will be 1 minus p x equal to 0, x equal to 1, x equal to 2 and x equal to 3. Okay. That will give at most at least, it is what? It is at least 4 calls. Okay. So, how we can compute this? It is again by the simple expression, it is e raised to power minus lambda dash here and into lambda dash raised to power 0 upon factorial 0 plus e raised to power minus lambda dash
into lambda dash e raised to power 1 upon factorial 1 plus e raised to power minus lambda dash raised to power 2 upon factorial 2 plus e raised to power minus lambda dash whole cube upon factorial 3. So, this is again equal to 1 minus, it is e raised to power minus 9 plus e raised to power minus 9 into 9 plus e raised to power minus 9 into 9 square upon factorial 2 plus e raised to power minus 9 into 9 whole cube upon factorial 3. So, whatever we can simplify this expression, and it is 9 into 9 into 9 upon 3 into 2 into 1. So, it is simply this thing. So, it is 1 minus e raised to power minus 9, 9 plus 1 is 10 plus 81 by 2 plus it is 81 into 3, that is 243 upon 2. So, we can simplify this expression and finally, we get the answer for this part of the problem. Okay. So, what I want to emphasize here is that lambda may change according to the problem. Here in this problem, for the first part lambda is 3 because we have to find in 1 minute time, but here in the second part we are finding the probability of receiving at least 4 calls in 3 minute time. So, we have to find lambda for 3 minute, fine. Now, in the third part, in the third problem, what is the third problem is, after correcting 60 pages of the proof of a book, the reader finds that there are on an average 4 errors per 10 pages. Okay. So, in every 10 page at an average there are 4 errors. So, what will be lambda for this case? So, lambda for this case will be 4 upon 10, that is 0.4, that is 0.4 error per page. Okay. We have to find out the number of pages one would expect to find 2 errors in 1000 pages of the first print of the book. So, how to find the number of pages one would expect if there are 2 errors. So, that will be what? So, that will be simply the required probability, the required expectation will be what? It will be simply given by, see, probability for x equal to 2 will be what? Will be e raised to power minus lambda square upon factorial 2, which is simply e raised to power minus 0.5 into 0.4 whole square upon factorial 2, which is e raised to power minus 0.4 into 0.16 upon 2, which is 0.08 into e raised to power minus 0.4. Okay. This is the probability of 2 errors per page. Okay. Now, in 1000 we have to find out the total number of pages one would expect to find 2 errors in 1000 pages. So, that the required value will be what? In 1000 pages, number of errors will be the number of expected errors will be what? Will be 1000 into 0.08 into e ratio minus 0.4. So, that will be further equal to, it is 80 into e raised to power minus 0.4. So, this is your required expected error in 1000 pages. So, this is how we can see some discrete distribution functions like binomial or Poisson, and how we can find out how we can solve the problems based on that. That also we have seen in this lecture. Okay. Thank you.